Selamat pagi, salam sehat, salam sejahtera buat semua. Jumpa lagi pada mata kuliah Enterprise Architecture atau Arsitektur Enterprise. Adapun topik yang akan kita bahas pada pertemuan kali ini adalah Teknologi Arsitektur atau Arsitektur Teknologi. Masih bersama saya, Leon Andreti Abdillah.
Assalamualaikum warahmatullahi wabarakatuh. Selamat siang. Salam sehat dan sejahtera buat kita semua. Selamat datang rekan-rekan mahasiswa yang saya cintai dan banggakan dimanapun Anda berada. Semoga selalu dalam keadaan sehat walafiat dan dalam lindungan Allah Subhanahu wa Ta'ala. Amin ya Rabbal 'Alamin.
Lecture untuk mata kuliah ini adalah Leon Andreti Abdillah, saat ini sebagai Associate Professor Computer Science and Information System pada Faculty Science and Technology. Kemudian juga bertugas sebagai asesor, reviewer, research fellow, dan editor. Asesor BKD di Kemdikbud, kemudian reviewer di Kemdikbud, research fellow INTI International University Malaysia, serta research fellow Tsinghua University Taiwan, dan menjadi editor pada sejumlah international journal dan conference. Mata kuliah yang diasuh antara lain adalah HCI, KMS, CRM, kemudian ada BPP, BPHEM, Databases, Data Structure, ERP, Information System, ITSM, Management Information System, Supply Chain Management, System Analysis and Design, Algoritma and Programming, dan lain-lain. Juga sebagai mentors, ini ada di Pablo, New Zealand, dan Unpad Indonesia. Kemudian ada sebagai consultant, baik di bidang akademik, research, dan community, serta koordinator pada Research Center dan Enterprise System Research Group. Berikut sejumlah mata kuliah yang diampu, dimulai dari System Analysis and Design, Enterprise System, Research Method, Human-Computer Interaction, Knowledge Management System, Human Capital Management, Algorithm Programming and Data Structures, Supply Chains Management, Business Process, serta beberapa mata kuliah lainnya.
This course explores the principles and practices of enterprise architecture, EA, a strategic discipline that enables organizations to align their business goals with their IT systems and processes. Students will learn how to design, plan, and implement an architecture that supports business objectives, enhances operational efficiency, and drives digital transformation. The course covers various EA frameworks, such as TOGAF, ZACMAN, and FEAF, examines how these frameworks provide methodologies and tools for analyzing and structuring complex organizational architecture.
Course objective: students should be able to do the following at the end of the course. Yang pertama, understand core EA frameworks and methodology. Ini termasuk dengan develop a solid understanding of major EA frameworks seperti TOGAF, ZACMAN, FEAF, and how they guide the alignment of IT with business goals. Yang kedua adalah align IT strategy with business goal. Learn how to design and implement enterprise architectures that ensure IT infrastructures, systems, and processes are strategically aligned with organizational objectives. Yang ketiga adalah analyze and design comprehensive AI models. Gain the ability to create enterprise architecture models that integrate business processes, applications, data, and technology in cohesion, efficient structures. Yang keempat adalah evaluate the role of EA in digital transformation. Explore how EA supports digital transformation by facilitating the adoption of new technologies, improving operational efficiency, and enhancing business agility. Last but not least adalah develop communication and governance skills. Learn how to effectively communicate complex architectural concepts to both technical and non-technical stakeholders, and establish governance frameworks to ensure EA effectiveness and compliance. Oke, sekarang masuk ke course expectation. Yang pertama adalah attendance dan enrollment. Jadi mahasiswa diharapkan secara reguler itu hadir ya, bisa secara offline ataupun online, termasuk juga dalam diskusi, dalam forum, serta kegiatan berkelompok. Yang kedua adalah task and assignment. Jadi selama perkuliahan Anda akan mendapati sejumlah tugas-tugas, bisa juga kuis, ujian untuk menilai seberapa capaian pemahaman Anda terhadap konten mata kuliah ini. Kemudian ada juga group project Mahasiswa diminta untuk bekerja secara kolaboratif, ya berkelompok untuk mengaplikasikan knowledge management principle ke dunia nyata yang mungkin ditemui. Yang pada adalah reading and resources. Nanti kita akan berikan sejumlah recommended reading and resources. Jadi diharapkan Anda mempelajari materi-materi tersebut sehingga dapat meningkatkan pemahaman dari subjek ini. Selanjutnya perlu diperhatikan juga regular office hours ya. Jadi kalau mau bertanya, konsultasi itu fokus pada jam kerja ya. Jadi saya meminimalkan kontak di luar jam kerja. Kemudian harus bersikap profesional, respectful ya, baik terhadap karyawan ya, dosen, rekan-rekan dan lain sebagainya. Kemudian communication juga penting ya. Jadi kalau mau bertanya itu harus jelas dan usahakan pada waktunya. Kemudian yang kedelapan adalah ethical conduct. It is critical to maintain academic and ethical integrity. Termasuk juga nanti ada kita harus menghindari yang namanya plagiarism dan juga cheating ya, baik pada saat belajar, tugas ataupun ujian. Kemudian tak lupa adalah feedback. You will receive constructive feedback on your assignment and project to help you improve your understanding and performance.
Application architecture is the blueprint and set of guiding principles that define how an application is structured, how its components interact, and how it integrates with other systems. It provides a foundation for building scalable, maintainable, and reliable applications, aligning application development with business goals as a key component of overall enterprise architecture.
Types of architectures. The first is layer architectures, where components organized into distinct layers. The second is microservices architectures, where small independent services communicating over a network. The third is the event-driven architecture. Components communicate by publishing and subscribing to events. And service-oriented architecture, or SOA, where applications build as collection of interoperable services. Various application architecture styles provide different approaches to structuring applications. Each style has its strength and weakness, making it suitable for specific type of applications and business requirements.
The design principles of application architecture within enterprise architecture, EA, are guiding concepts and best practices that align application development with an organization's business and technological goals. These principles ensure applications are scalable, maintainable, secure, and adaptable to both current and future needs. When integrated into the EA framework, they provide a structured approach to building flexible, efficient applications that can evolve with the business. Cloud deployment involves hosting applications on external cloud platforms for flexibility and scalability. On-premise deployment hosts software on local servers, providing full control over security and data. Hybrid deployment combines both cloud and on-premise solutions, offering flexibility while maintaining control over critical data. Each strategy is suited to different organizational needs and infrastructure requirements. Effective deployment practices include automating deployment processes, continuously testing software, and utilizing containerization technologies. These practices not only minimize deployment risks, but also enhance agility, allowing teams to respond swiftly to changes.
The purpose of this meeting is to provide an overview of enterprise architecture, EA, outline its role in aligning IT strategy with business goals, and set expectations for the course. We will discuss key concepts, frameworks, and methodologies that form the foundation of EA, as well as the practical benefits it offers in driving organizational efficiency, agility, and innovation. This session will also establish the structure and objectives of the course to ensure participants are well prepared for upcoming topics.
Our agenda for this meeting is divided into 5 subsections. The first is technology architecture as an overview. We'll discuss the definition of technology architectures, overview of technology layers, importance in enterprise architectures, key components, and interrelation between layers. After that, infrastructure design, we'll discuss components of infrastructure designs, building the foundation, best practices, and case studies. After that, network architectures consists of key components of network architectures, design principles, challenges and solutions, and connection types. Then cloud models. We'll discuss types of cloud computing models, option and consideration, benefit of cloud adoptions, impact of cloud computing, and cloud architecture best practices. Lastly, IT security architectures consists of fundamentals of IT security architectures, risk management strategies, protecting enterprise assets, and compliance considerations.
Enterprise architecture, EA, comprises 4 key domains. These are business, data, application, and technology. Each offers unique perspectives. These are essential for strategic alignment.
Oke, sekarang baru masuk ke penjelasan masing-masing domain layers. Each domain can be described as follow. Ini kita ambil dari All Sophie pada tahun 2014. Yang pertama adalah yang paling atas yaitu business domain. Ini represent the function and processes that support the business, the organization that perform the business process, and the location where the business is performed, and the factors that could cause the business to change. Jadi isinya itu bisa saja terkait proses atau fungsi yang mendukung bisnis. Kemudian bisa juga prosesnya, lokasinya, ya, serta faktor yang menyebabkan bisnis itu dapat mengalami perubahan. Kemudian di bawahnya ada information atau data domains. Identify the major types of information needed to support the business functions. It identifies and defines the information models, datasets, metadata repositories, and their relationship to the business functions and to application system. Jadi fokus pada model informasi, set data, metadata repository, serta hubungannya dengan business function atau ke sistem application. Selanjutnya pada layer ketiga yaitu application domain, identifies and describe application and modules as well as their relationship to business processes and other application system and modules. The application architecture identifies the major application needed to support and cross-cutting business processes and of the enterprises. Jadi dia mengidentifikasi dan mendeskripsikan aplikasi apa saja yang dibutuhkan beserta modul-modulnya serta hubungannya dengan bisnis proses atau pada sistem aplikasi dan modul lainnya. Kemudian ada juga infrastructure technology domains, ini yang paling base ya. Identifies the major technology or platforms necessary to support the enterprise's application and data system and associates those performs platform with the various application in the other sectors. Jadi dia mengidentifikasi teknologi utama apa yang digunakan atau platform apa yang dipakai, sangat penting untuk mendukung bagaimana aplikasi enterprise dan data sistemnya itu dapat terasosiasi dengan baik. TOGAF architecture domains. TOGAF focus on 4 main architecture domains. The first is business architectures, define the business strategy, governance, organization, and key business processes. Second is data architectures, describe the structure and management of organization data. The third is application architectures, describe the software application needed to support business processes. And the last but not least is number 4, technology architectures, cover infrastructures, platform, and technology required to support the application architectures.
Technology architecture is a structured framework used to align technology with business goals. It encompasses hardware, software, networks, and security protocols, ideally representing how an organization's technology is organized and operates. Technology layers in enterprise architecture refer to the distinct yet interrelated domains that define the technological landscape. They include aspects such as business logic, data management, application platforms, and infrastructure. Understanding these layers allows organizations to align their IT strategies with business goals. Technology architecture plays a pivotal role in aligning IT strategy with business objectives. It helps in optimizing resources, ensuring scalability, and guiding technology investments to meet future needs. The key components of technology architecture include applications, data management systems, infrastructure, servers, storage, network components, and security protocols. Each component interacts to form a cohesive technology ecosystem that underpins enterprise operations. The interrelation between technology layers underscores the necessity for effective communication and integration among them. Changes in one layer can impact others, necessitating robust governance and coordinated strategies to manage dependencies. This holistic view promotes agility and responsiveness within the IT environment. Infrastructure design focuses on the foundational technology components that support organizational systems and services. This includes the specification and integration of hardware, networks, storage, and cloud platforms to ensure scalable, secure, and reliable IT environments. Effective infrastructure design aligns with business requirements, supports application performance, and incorporates best practices for high availability, disaster recovery, and cybersecurity. This meeting will outline the principles, patterns, and standards that guide infrastructure decisions to ensure long-term operational efficiency and adaptability. Infrastructure design encompasses the hardware, software, networks, and facilities required for IT operations. Key components include servers, storage systems, networking equipment, and data centers. Effective infrastructure design supports performance, reliability, and scalability, which are vital for business continuity. Infrastructure design lays the groundwork for IT. It supports all IT operations. Effective design ensures reliability. Scalability is also key. Implementing infrastructure design best practices involves adhering to principles such as modularity, redundancy, and load balancing. Optimization of resource utilization and proactive monitoring can enhance performance. Additionally, leveraging virtualization and cloud solutions can lead to cost efficiencies and improved responsiveness. Examining real-world case studies provides valuable insights into successful infrastructure design implementations. These cases often highlight specific challenges faced, solutions developed, and outcomes achieved. Analyzing such instances helps inform best practices and encourage innovative approaches within organizations.
Network architecture, a key element of technology architecture and enterprise architecture, outlines the structure and management of communication systems connecting applications, services, and devices. It ensures secure, reliable, high-performance connectivity using technologies like software-defined networking, SDN, network virtualization, and hybrid cloud integration. A well-designed network supports scalability, fault tolerance, and policy-driven access, aligning with digital operations and strategic enterprise goals.
Network architecture is the blueprint for connectivity within an organization. Key components include routers, switches, firewalls, and access points, which together facilitate data transmission and ensure system security. The design must also account for bandwidth requirements, latency considerations, and redundancy to prevent downtime. Effective network architecture adheres to several design principles, such as scalability, reliability, and security. Scalability ensures that the network can grow alongside the organization, while reliability minimizes the risk of failures. Security principles must be integrated throughout the architecture to protect sensitive data and maintain compliance with regulations. Common challenges in network architecture include congestion, outages, and security vulnerabilities. Solutions may involve implementing quality of service (QoS) to manage traffic, developing robust disaster recovery plans, and employing advanced security measures like intrusion detection systems. Continuous monitoring and management are vital for adapting to evolving threats. Network architecture designs communication. This includes the internal and external connections. Security is a major factor. Performance also matters. Cloud computing allows organizations to access and utilize computing resources, servers, storage, databases over the internet. It offers flexibility, scalability, and cost-effectiveness, enabling businesses to quickly adapt to changing demands without investing in physical infrastructure. Models include IaaS, PaaS, and SaaS, which provide different layers of services depending on user needs. Cloud computing can be categorized into several models: infrastructure as a service, IaaS, platform as a service, PaaS, and software as a service, SaaS. IaaS offers virtualized resources over the internet, PaaS provides a platform for application development, and SaaS delivers software applications via the cloud. Each model meets different business requirements. Cloud computing offers diverse models. Each provides unique benefits. Choosing the right model is critical. Cost and scalability are important. Adopting cloud computing presents numerous benefits, including cost savings, scalability, and enhanced collaboration. Organizations can reduce capital expenditures by utilizing pay-as-you-go models and easily scale resources according to demand. Furthermore, cloud solutions facilitate remote access and improve team collaboration across geographically dispersed locations. Cloud computing has a profound impact on technology architecture, allowing organizations to reduce costs, enhance scalability, and improve collaboration. The shift to the cloud also necessitates re-evaluating security measures and data management strategies to adapt to a distributed infrastructure. Implementing best practices in cloud architecture is essential for maximizing efficiency and security. These practices include designing for fault tolerance, utilizing automation for deployment, and ensuring data encryption both in transit and at rest. Organizations should also regularly assess their cloud configurations to align with changing business needs and compliance requirements. Security is a fundamental aspect of technology architecture. It involves implementing measures to protect data integrity, availability, and confidentiality. Organizations should adopt a proactive security strategy, incorporating technologies such as firewalls, encryption, and access controls to mitigate risks.
IT security architecture encompasses the structural design of security controls, policies, and technologies within an organization. Key aspects include understanding potential threats, defining security requirements, and establishing a framework for risk management. It is essential to build a comprehensive security architecture that aligns with business objectives and regulatory demands. Effective risk management strategies involve identifying, assessing, and prioritizing risks to organizational assets. Strategies may include implementing layered security, conducting regular security assessments, and employing incident response plans. Continuous monitoring and adaptation of strategies are required to address emerging threats and vulnerabilities. IT security architecture safeguards data. It protects systems from threats. A strong architecture is essential. It defends against cyber attacks. This helps maintain trust. Organizations must navigate various compliance frameworks and regulations, such as GDPR, HIPAA, and PCI-DSS. Ensuring compliance requires a thorough understanding of applicable laws, continuous monitoring of security practices, and the implementation of necessary controls. Non-compliance can lead to significant financial penalties and reputational damage.
Future trends in technology architecture focus on cloud-native systems, AI-driven automation, edge computing, and zero-trust security. There's a growing emphasis on adaptability, sustainability, and modular, composable infrastructure to support digital transformation and evolving business needs.
The integration of AI and machine learning into technology architecture is transforming how organizations analyze data and automate processes. These technologies enable predictive analytics, enhance decision-making, and create tailored customer experiences. As machine learning models evolve, they will streamline operations and drive innovation across industries. Blockchain technology is emerging as a secure and transparent solution for various enterprise needs. Within technology architecture, it can enhance data integrity, enable decentralized applications, and improve security through immutability. Its potential for smart contracts and supply chain management showcases how blockchain can foster trust and efficiency across systems. As organizations increasingly prioritize sustainability, integrating green practices within technology architecture becomes critical. This includes optimizing energy efficiency, selecting sustainable materials, and minimizing waste associated with technology operations. A focus on sustainability not only meets regulatory requirements but also enhances the organization's brand reputation and stakeholder trust.
Technology architecture is a vital component of enterprise architecture, facilitating alignment between IT and business strategies. By understanding key components, frameworks, and emerging trends, organizations can more effectively implement technology solutions that drive growth and innovation. Future advancements in AI, blockchain, and sustainability will reshape the landscape, necessitating continuous adaptation and learning.
Assignment of technology architectures. Explanation of technology architecture concept and principles. A brief case analysis of how technology architecture supports specific organizations. And a simple architecture design task with the corresponding explanations. Students should include a basic diagram to illustrate their designs using any suitable tool or hand-drawn and scans. Save your assignment in Word or PowerPoint as EA class technology architectures. store it in Dropbox, and paste the URL from Dropbox into the submitted URL.